All right, welcome. Today, we are going to crack a code that's right at the heart of how computers work and see the world. We are talking about hexadecimal numbers. You know, the language behind the colors on your screen, your computer's memory, pretty much everything. So let's just dive right in. So, you've probably seen these weird-looking numbers before, right? Things like F5 or 1C3. They look like this jumble of numbers and letters, but somehow they represent a single value. I mean, how on earth does F5, with a letter in it, magically turn into the number 245? It kind of seems impossible. Well, today we are pulling back the curtain and we're going to solve this puzzle together. The secret key to this whole thing, the thing that makes it all click, is one really powerful idea: position. To crack this hex code, we first have to get our heads around what base 16 actually means. And trust me, it's all about where each digit sits. Okay, so first things first, the normal number system we use every day, decimal, has 10 digits, right? 0 through 9. But hexadecimal, or hex for short, is base 16. So it needs 16 digits. What does it do when it runs out of numbers at 9? Simple. It just starts using letters. A is 10, B is 11, C is 12, all the way up to F, which is 15. That's the first piece of our puzzle, right there. Now, here's the part that makes it all make sense. Think about our regular numbers. In the number 123, you've got the ones place, the tens place, and the hundreds place. Well, hexadecimal has the exact same thing, positional values. But instead of being based on powers of 10, it's all about powers of 16. So starting from the right, you have the 16 to the 0 spot, which is just the ones place, then the 16 to the 1 spot, then 16 squared, and so on up the line. This is our secret weapon. So, we've got our two secret keys. We know what the letters mean, and we understand the power of position. Now it's time to put them together and crack some actual codes. Let's see this thing in action. Let's start with our original mystery number, F5. This is the first lock we're going to pick with our new set of tools. Okay, so watch this. We always start from the right. The first digit is 5, and it's in that first position, the ones place. So that's just 5 times 1, which is 5. Easy enough. Now we move one spot to the left, to the F. This is in the 16's position. We know from our chart that F is really 15, so we multiply 15 by 16, which gives us 240. And the final step? Just add them up. 240 plus 5 gives us 245. And there it is. No magic, just math. The mystery of F5 is officially solved. This shows you perfectly how the digit's value and its position work together. Feeling good? Awesome. Let's try a slightly longer one. 1C3. The process is exactly the same, we just have one more position to think about. Okay, same deal. Start from the right. The 3 is in the 1's position, so that's just 3. The C is in the 16's position. We know C is 12, so 12 times 16 is 192. And that 1 all the way on the left, well, that's in the 16 squared position, or the 256's spot. So 1 times 256 is 256. We just add them all together, 3 plus 192 plus 256, and we get 451. The pattern holds up perfectly. Once you get this rhythm down, you can convert any hex number. It doesn't matter how big it is. All right, one last practice round to really make sure this skill is locked in. Let's do 16E. I bet you're already starting to do this in your head, right? Let's break it down one last time. From the right, E is 14. It's in the ones place, so that gives us 14. Next, the 6 is in the 16's place, so 6 times 16 gets us 96. And the 1 is in the 256's place, which is 256. You know what to do. Add them all up. 14 plus 96 plus 256 equals 366. And there you go. 3 for 3. We cracked every single one using the exact same logic. You've officially seen the whole system in action. So, what did we really learn here? We've basically put together a universal toolkit, a 3-step master formula that you can use to convert any hex number into a regular decimal number. Let's just boil it down so you'll never forget it. Here it is, the whole thing in 3 simple steps. 1. Assign the positional powers. Just start from the right with 16 to the 0, then 16 to the 1, 16 squared, and keep going. 2. Multiply. Convert any letters to their number value and multiply each digit by its positional power. And 3. Sum the results. Just add up everything you calculated. That's it. That is the entire method for cracking any hex code. So you've just learned how to read one of the fundamental languages of computing. You can look at a hex color code online and know it's not just a bunch of random characters anymore. You've cracked the code. So I'll leave you with a final thought. Now you can read hexadecimal, but could you write it? Could you take a number like 255 and turn it back into hex? Well, that's a puzzle for another time. Thanks for joining me on this code cracking journey.